does this say that we're recording on here? But it does not. So, but we'll go ahead anyway.
It's recording.
So I assume everybody can see my screen. It says astrophotography topics. Okay.
Yep.
Having nobody said anything, then
Yes.
then I must be fine. And we're basically going
Hey,
to. Yes, sir.
Sorry, just real quick. How do you want people to ask questions? Directly over the microphone or through the chat?
We're small enough tonight. Let's do it right over the mic.
Okay. It'll make it a little bit funny in our conversation just because of the Vodex, but that'll be fine, I think. And we're just covering two things tonight. I'm going to be covering Mure Denoise, which you're really going to like it. I'm going to tell you this, that you're really going to like it. And then Mark will cover background or dynamic background extraction, which will do better, particularly on the M33 object that we have supplied. So let me go to the presentation. Oops, not that button, this button. There we go. So I'm going to talk about Mure Denoise, and in particular, we're going to talk about why, when, and then how you use it. And during the how, I will actually do a demonstration. Do we have somebody else join in?
No, it's just me.
Okay.
Change my volume.
So I wanted to go a little bit in the background about why we do this, because it applies in several of the decisions that we make in astrophotography. So we know that there are noises in the image. So if you look at the image that I have on the right-hand side here, ignoring the star, you can see quite a bit of variation in that background noise. Some of them are brighter, some of them are darker. Given this is stretched, this is a stretched image of a raw file, not a raw file. Oh yeah, it is a raw file. So this variability is not something we want with the background, at pixels that should be that close together. And those pixels are about 1 arc second. They should be fairly close to the same value, but they're not because of noise. Now, a couple of years back, somebody asked me, well, shouldn't it always get brighter? Shouldn't it also, why would light combining get darker? And to answer that question, you need to understand that light does have a property of a waveform, and constructive interference will amplify that light. Destructive interference of two light waves coming at you where they cancel each other out. So it is possible to get brighter values and darker values than the one that you want. So the other thing that is true is that this is just one shot, but the same thing is true when you go from picture to picture to picture. If you look at the same point in the sky, you will also see this variability, which means that the light is not always the same as it comes in. And I took 1 pixel out of the nebula, out of the galaxy on M33. So I registered the images, and I went to the same pixel, and I took measurements. I wrote down the values of all 33 or 32 frames that I had accepted. And you can see those measurements on the left-hand side, starting with 1598, and then getting higher and lower values. Let's see, anything? Yeah, there's 1518, and if I graph those in a histogram, you can see that there's quite a variability. It ranges from 1474 on the down here. And then the maximum value around 2265. So, the question is, well, what is the right value for that particular point in the sky? And we don't know because of this noise. The So what we need to do, and what people have done, is to find a general case for that noise that can be applied then to specific cases, to all cases. If you take enough data, like 50 hours or something, then you will get something that looks like the graph that's over there on the left-hand side, which is basically, it looks like a bell curve. So here we get to step into the realm of statistics for those that didn't really want to talk about it, but or wanted to take that class. So the noise that we get from the sky is statistical in nature, and we can pretty much, or it's been measured, or it's been figured out that if you take all of these values and average them together, then you're going to get pretty close to the value that you want. The distributions usually come in two forms: a Poisson distribution and a Gaussian distribution. Gaussian distribution is one that most everybody is familiar with. So, and like I say, the data gives us a good clue as to what the real value is. And if you look at, if you do image integration, or I don't know if it's in WBPP, but there's a method of combining them. How do you want to combine them? And the average then is a good estimate of what that real value is. This is why, just an aside, this is why you want to take more data. You know, if I go with this data, which is 33 frames, 5 minutes each, then, which is, you know, a little less than 36 hours, you know, how good is my estimate going to be? If I were to be able to take this many samples, which is, I think I generated this graph in Excel, and I think I used somewhere around 20,000 values. So if I had 20,000 values, then I would have a better estimate of what that value should be. So if you want to know why I take 3 hours of data, this is why. I can get a better estimate of what that value actually is, and it just makes it better. So, but to continue on with the presentation, or with what I'm talking about, Mure Denoise is a tool that they have. It's a script that helps reduce the noise that you see in the image based upon the statistical model. Now, if you actually go into Mure Denoise and look at the documentation for it, it'll give you the equation if you wanted to delve in that far. I looked at it and said, yeah, I don't think I want to look at that anymore. I know what it's doing. I just don't need to know the specifics. So now, when do we apply this? There are really two places where you apply this, and it depends upon your situation. One is on the individual calibrated and corrected frames. And there is a way to do that. I've never done it. I'm going to have to do it because I want to collect data on several different nights. And so I'll want to calibrate each of those, or do denoise on those individual frames, and then I'll pull them in and figure out which ones I want. This is the big program I've been working on getting all of the veil.
Hey, Doug.
Yes, sir.
Why would you do it separately to individual nights? Is that because your camera isn't exactly the same and you're gonna have a different set of light, different set of flats for that?
I do flats every time I go out. I do flats.
Okay, then that makes sense to me.
Then and darks. I do darks and flats every time I go out. And rather than using a library, I just think I just do it. It doesn't take that much work to get it done. Flats take very little time. Darks take quite a bit of time, but I'm out there enough before it gets dark that I know what values I'm going to use. So I just do my darks. So I just do it every night. And you know, it would be a good exercise to figure out whether the values that change from night to night. I don't know whether it does or not. That's a good question.
Well, I understand why you do it, because, you know, if you're tearing it down every night between sessions, well, then your flats are going to change. So then that makes sense why you'd want to do it and process each one of those nights separately. I get that. But for me, okay.
The other
everybody.
thing, the other thing is that you can only apply a denoise on a Mure denoise on monochrome images only. Now, that doesn't mean you can't do it on OSC. There's just a couple of extra steps that you'll need to do. And we're actually going to, I will demonstrate how that's really kind of done tonight. So this is the process that you use to do this on OSC data. So we're going to determine a couple of gain and Gaussian noise values. There is a script that will do that for us. Then from the master light, we're going to extract the luminance out. Then we'll apply the Mure denoise to the luminance image, and then we're going to pull that luminance image back into the OSC image. So that's really the 4 steps that are required. So we need to determine some statistical values first, and that's done with this open script noise reduction Mure Denoise detector. You have to load in 2 flats and 2 darks, and then you click the estimate button, and then you go record this information in here. And I'm going to do that right now if I can get to PixInsight.
Just a quick comment on that. Those are flats which have not been calibrated.
They are uncalibrated, yes. If I go, not processes, but script, noise reduction, noise, Mure denoise detector settings. And then what you do is, this is an uncalibrated flat, so there's 742, 743, 2 darks, 757, 758. And once you have that, you just hit estimate and it'll go off and think for a little bit. And this is slower tonight than it usually is. There we go.
Slow computer.
So it gives me a gain. These are the 2 numbers that you kind of need to write down. There's no way to transfer them. So here's the gain and the Gaussian noise. And those are the 2 numbers that you really need. I'm going to dismiss this. And I'm going to change my workspace to workspace 2, which has, this is our master light. And let me stretch that. Actually, let me process all processes, screen transfer function, unlink the channels, and then redo it so that we get something that looks reasonable and looks better. So yeah, we go in here and we can see, you know, all sorts of noise. So now with those values, we can't do anything yet, because if I try to do the script processing, noise reduction, Mure denoise. So if I wanted to do it on this image, you can see that it's there, but it won't really take that. And it says you can't do this because it's not a monochrome monochannel image. So we need to extract out. Let me close this. We need to extract out first the luminance. Now this is where this ribbon will come in handy. And if you make sure, let me go back. I get into this. There we go. Enable the image section on your ribbon tool if it doesn't have done. So you go up here and do a right click in this area. You can see all of these, and image, you can see it's gone now, is the tool that supplies you a couple things. This one actually will take out all of the red, green, and blue channels, split them out into separate images. This one will extract the luminance. So all you do is to click this, and this is then the luminance image. All the colors have been combined. You can still see it's noisy, but it's just the luminance, no color in here at all.
So can I ask a quick question? This image, what you're working on, is just after the everything, the integration is done, right? Before.
This is after integration. So, yeah,
Okay.
if we go back here, yeah, I said there were two places to do that. We're doing it on the second. Oops.
Okay.
The second one on a single calibrated stack image. So this is basically right before background extraction, be it automatic or dynamic.
Okay.
So here's actually the same image. Here's the luminance image that I would apply things to. So to actually apply the luminance on here, and let me get over to the side, script noise reduction, Mure Denoise. And usually it'll come up with the right one. You have to put in, let me go over here and make sure I got everything that I need to talk about. You enter the number of lights used, enter those two numbers that we use the Mure Denoise detector on. Those get entered right in there. Then you play with this number, this variance scale, each time hitting denoise. So you just try to find the best value you can. And I have two examples of where I put this variance. So I don't select a flat field. I'm not sure how much different it does. I haven't used it yet. You and I looked at that the other night, Mark. I can't remember what.
Yeah, I don't remember
what
how
it said. Anyway,
I don't remember how it worked out either. But I guess I always use a flat frame there. I always use my master flat there. And I don't know any better, so I've only done it with the master flat, so I don't know how it works out without it. And I don't exactly know.
it probably looks like it would do better, but as I look at this,
So
the flat field must be bias or dark subtracted, so it needs to be calibrated at the least. You're using the master.
yeah, I use the master.
Yeah. What was our last comment in there? Okay.
So another comment I have, Doug, before you go too far. So your master light that you're using, that combination count, typically that will read that out of the fits header. Just to let everybody know, if you forget, it'll read it out of the fits header anyway. So I don't think it's critical that you go and check to see how many subframes you integrated.
That's a good question. Let's show them this since we're on the side here. Oops, I got to close this thing.
Yeah, close that before you can do anything. Okay, I'll be quiet.
There is a fits header, so we can select the view, master light integration. So this is all of the things that are in the fits. There's the exposure time, 300 seconds.
It's down.
I don't know, so let's see that it's
There it is right there.
in here.
It's up, Doug. I saw it.
Did you?
Yep, it's right. Scroll down just a few lines. Yeah, scroll down. It's in the history there.
Oh, okay.
I saw it. There it is, right there. Right by your mouse, 33.
One
There it
down.
is. There you go. So you can look it in there. It reads it out. I don't recall it reading it out, but I'll believe you.
It does. Because I never enter it. It just puts it in there. Reads it out of the fits header.
There's all sorts of information in this fits header. So there's
it's kinda
a
scary.
plus for you. There's the RA in the deck. So anyway, let's close that. So once you have noise reduction, Mure Denoise, the luminance, when you extract, it actually puts an L on the end of the name, so that's how you know it's the luminance. Get that in. I leave this alone. There are several choices in here, but I just leave it alone at this point. It's giving me good data, good results anyway, so I'm not too worried about it. Enter these two numbers, and then you're going to play with this variance scale. I don't play with the spin count very much. And then you hit denoise. I'm not going to do it because that will take a long time and take some processing power, and you probably wouldn't be able to hear me for a while. So, but what I have done That's the luminance. I think this one has the noise applied. This one does not have the noise applied. So this is what it looks like before, and this is what it looks like after I did that. Did the denoise. Now, if we go back to the presentation, I actually have a couple examples here. Here is a before and after with the variance value of 1. And you can see it actually made the situation maybe a little bit worse. This is the same place in the or the same point in the image. Who was that? Was that somebody else joining in, or is that?
No, it was
Okay.
It's not like somebody's
Alright.
pizza was ready.
So you have to play with it. I did 1.0 to begin with, and then I decided I'd try 0.5. This is again the same area, and you can see that the variability, the noise. This should all look the one on the left. It doesn't look all the same. It should be about the same value, and you can see that on the after applying it. It looks much nicer. Again, these are the luminance images. Taking out this variability makes processing further down the line, especially when you do MLT, multi-scale linear transform. Is that it? Yeah. Makes your life a little bit easier there. It'll make your pictures look better. Let's actually apply this. So now I have, this is my light. And this is the image, the luminance image where I've run the denoise. And now we need to move this luminance value over to here. And we do that with a process that's called, what's it called?
LRGB.
Combination.
Yep.
And I can combine all sorts of stuff, but I don't want to do that. I only want to combine on the luminance. So I turn all of those off. In here, I'm going to take, yes, this one. I got this other one running around here just for examples, and so it's, I just got to make sure I do it right. I leave everything else the same. Let's actually close this down because we're not going to apply it to that. And then we take this and apply it to here. Dum, 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 da, da, dum, dum, dum. There we go. We're done. Now, if we go in and look at our image, just zoom in so we're seeing individual pixels. I'm going to undo. I'm going to redo. And you just see it just smooths it out. We still got some chrominance, and there's still a little bit of, I might be able to find better values. A lot of it is just how much time do you want to experiment around. But it significantly reduces the noise. This is, I think, a game changer that I learned last fall and started using. I'll go back, now that I have a new process that has this in, I'll probably go back and do some of my older pictures and see what kind of a change it'll make. Oops. I'm going to go to, I didn't want to go to that one. I want to go to this one.
Hey, Doug.
So I think there's the LRGB combination, and I think that's the end of my presentation.
Hey, Doug, can I ask a question?
Yes, sir.
So the main point of this is for monochrome only, and the main point of this is obviously to reduce noise, right?
Yes.
So I'm thinking to myself, this year I'll be using my 1600 Pro, which is a cooled camera. And so it's going to be, that cooled camera is going to have less noise to begin with, right?
Less camera noise, yes.
Camera noise. So how much of a benefit will this be for me?
I think that you will see a benefit. You also get noise from space, especially if the moon is out. Without getting into too much,
it's background.
It's background noise, and so you still get this kind of a distribution from the sky. So just because your camera is cooled and there's less sensor noise, it doesn't. That will reduce it, and it won't reduce it completely, but there is still noise from the sky, from light pollution, and from space itself, where you'll see this noise. So it doesn't take that but 5 to 10 minutes to run, depending upon how fast your computer is, Suresh.
There's an inside joke, guys.
I had to help him make his computer faster at one point.
And then every time his computer is slow, I got to bring it up.
And so you will see some effect. And if you don't see an effect, I guess you don't see an effect. That would be interesting to hear. But I think you will see. I think you will see something.
And there's no way this will be a benefit to my D810A.
Yes.
Yes.
OTF.
Yes.
It will or will not.
Yes.
But I thought this was monochrome only.
You are. What's that?
Didn't you say that this is monochrome only?
Yes, but what you need to do is to extract the luminance,
Okay.
do a denoise on the luminance, and then once you've got the denoise done, use the LRGB combination to bring your luminance back in. This is I've done a Mure Denoise on it, and this is as you can see, a color image. So yes, you can do it on a monochrome or on an OSC image, on a CFA image. I guess they talk about it. Color format array, and so yes, it will help you.
Good deal. Thanks.
Oh, everybody else, no questions?
They're befuddled.
It's kind of interesting.
All right, I'm going to stop presenting, and I'm going to turn it over to Mark, who is going to do some DBE stuff. I'm going to get my notes pad and take notes while he talks.
Oh. I don't know if I have.
Oh, by the way, there will be no quiz at the end, just so you're okay.
Yes.
All right, Mark, go ahead.
Yeah, I'm here.
Hey, Suresh, what telescope is in the back? The white one.
Sorry, I missed that. Could you say it again, please?
What was that?
No, I said what telescope is that in the back? In your
You got a refractor behind you, Suresh?
yeah.
I'm not sure what you guys are seeing. You see my Dob?
No, the white.
No, it's not your Dob.
I seem to be.
Turn around, look up. It's in front of the window.
No, you're muted. You're muted.
I'm all sorts of problems. This one behind me here,
Yeah.
that's the Unitron 150. It's visual only, so.
Okay.
That's a 4-inch Unitron from 1958.
How many telescopes you got in your basement
Right now or
Sure.
usually?
right now?
Because I'm packing for Oklahoma. Right now, I probably have about 12.
Wow.
Yeah, the other ones are in my car.
Did everybody see my screen?
Yes.
Yep.
Right, excellent. Okay, here we go. So I want to show you, let's see, I'm going to set this off to the side. And I just want to show you a couple things. Actually, no, let's do this the way I was going to do it. So I'm going to do a dynamic background extraction demonstration. I don't have any slides, but since this is recorded, you'll be able to see all the settings I use. So what I did is, to get ready for this, I really wanted to do I've always wanted to do the experiment of what's the difference between ABE, automatic background extraction, and DBE, dynamic background extraction. I really wanted to see what the difference is. And part of me that got me excited about that is, Bala, when you were going through and using this data, and you created some stuff that I went, wow, that's ABE. I went, that's wow. That's why I guess I always use DBE. Is where that came from. So that motivated me to get involved and do this demonstration and do some experimenting. So what I did was, let's see, do I want to do it on this one? Yeah, let's do that. Let's do it on this. So what I did is I have ABE, and I included ABE in the project that I sent you. So if you open up the project, you're going to get the RGB frame, which is this RGB frame. And I'm only gonna work in RGB space tonight. I gotta check one thing, make sure I haven't done anything to this. Okay, so we're good. So what I'm going to do is I'm going to show you what happens when you use it just with defaults, right? Stock out of the box, as I like to say. So this is the default setting that comes with PixInsight and when you run it. So let's see, I always do subtraction. And the reason, so I guess I want to spend a little bit of time about why do we do subtraction? Well, when we acquire our subframes and we calibrate those and we align those and then we integrate those, that is all, we're adding all those calibrated and aligned subframes together. So that's addition. So all of that noise that's being transferred to our final master is added. I was reading something recently going, okay, well, what's with this subtraction? Where would you ever use that? And I guess I found it in when you're working with your calibration frames is one place where you would use division. And I don't exactly know why, but that was one place where I read you would do division. And also there are some other places where if you really have some nasty noise and because of whatever, light pollution or camera noise or a combination of that, and you combine that with your flats, and maybe you don't have a really great library of flats, and you kind of create a bigger mess than you maybe had if you didn't use the flats. Well, there's a possibility that you could use division and go in and subtract some of the mess that you made. I know that's one way of doing that. But before I go too far, let's just go in and take a look of what do I have in this thing for noise. And it's not bad. And I don't remember how many frames this is. Paula, maybe off the top of your head, you remember how many frames this was. I gave you how many?
33.
Is it? This is M42.
Oh, hold on a second.
Okay, hang on. Here, I can do it. I'll just do it real quick. So it's a good exercise. Everybody can see it. So here's the Fitz header. There's 40. I can see it right there. There's 40. So this is 40 frames, and they are. It's off my one-shot color. Which one-shot color? It might be the 294.
Mark,
Yes.
did you do a Mure Denoise on this?
No, I didn't. Not on this.
Okay.
No, actually, like when I was looking at noise, the noise was so low.
Right. That's so this isn't too bad. So this is 5-minute subs. These are unguided. So, and these are Minnesota frames. Just to let everybody know what is that data. So, all right. So, there's an idea what the noise looks like. And when I get to get my first master light and I start playing around with DBE, before I even apply DBE, I like to go in and look. What do I have for noise? What does it look like? I go in and zoom way in. what do we really have? And so this is, I agree, it's not that bad, but I would still apply ABE or DBE. It's not too bad. And so when I do it, my first run of ABE or DBE, I usually go to the image target, the target image correction section of the process, and I put this to none, and I turn off all this stuff because I just want to see what the background is. So it created a new frame. That new frame is only the background. It didn't do anything to my image yet, but there it is. All right, I got to do something. You can unlink this. Let's see, take that stretch off. Oops. There we go. So what I'm looking for is, and I'll say this probably a few times tonight, is I want to look at that background. I want to see what's going on. To me, it looks like it's really working hard on the nebula part, and not so hard on everywhere around. And so if I take this and I want to compare it to, oops, I can't do it that way. I have to do it the other way. I know what I'm trying to do. Really, I do. I want to look at the same place in the background as I'm looking at in the frame. Did that do that? Yeah, so this is the same place. If you take this and you lay it over the top, that's really all it's going to do. So, to me, ABE it's a little weaker tool. I mean, I think you really got to have perfect data to do it. So, all right, so we'll get rid of that. And now let's just see what happens when you do subtraction. In this case, I'm going to discard the background model, and I want to replace the target image because I want to keep the target image. I want to look at it again later. And so we'll apply it, and we'll just see what we get. So this is what ABE does in default mode. It doesn't do the image any good, in my opinion. It leaves this ring around it, which to me, it should have been working just as hard on this ring around here as it did like in between the Running Man Nebula and the Orion Nebula. It should have been working just as hard in these areas.
And this is the same thing that we're seeing on that M33 object.
Right, and even when you run ABE, so this is a common ABE problem, and that's why it's fine if you're going to crop it all out, but I don't know. I'm not a big cropper. I mean, the most I'm going to crop out is I'm going to crop out the artifacts from stacking. So this is ABE in default, and I'm going to get rid of it. I don't want to see it anymore because that just doesn't work very well. And I'm going to close this, and I want to open this one here because this is with my settings. And I'm going to do the same thing. I don't want to replace it, and I want to actually let's do this the way I usually do. Let's do none here. So let's look at that background again, and we'll stretch it. So now it's with my settings, and all it did is it changes the box and the separation of the box. So it's placing these samples, the samples that it's going to look at to apply the noise reduction. it's making bigger boxes and it's placing them a little farther apart. It does a little better, but still in my mind, it's not doing very well in the corners, which in my mind is kind of a problem anyway, because, you know, I think there's always a little bit of vignetting on really any scope. It's just one of those things. So all right, let's get rid of that.
You're done?
And let's apply that then. Let's do our subtraction. Let's discard the background because we already looked at it, and I wanted to give me that final image. So, you know, it's still not. Oh wait, I double stretched it. I'm sorry. So there's a single stretch. I mean, exactly where we thought we were going to have issues, there are issues in the corners. You know, it does okay in this area here, but it's no DBE. I'll just say that. All right, enough of that. So let's.
Yeah, I just tried it on an image that I have, and yeah, it's a Andromeda galaxy, and it takes up the whole frame, and there's a nice halo.
Yep.
All the way around it. It's ugly.
It is. So let's get into DBE then. Let's talk about that. So we've looked at the noise that's in this image, and so we kind of know what we're up against. So let's see. Where's my DBE? DBE. I want. So this is DBE in a default. In default as it comes to you out of the box, so to speak. So these are the things that I have learned that work for me. Oops, that's not the one I want. I want this one here. What I usually do is I go in. How come that's not live? Let's see. There we go. Now I know I'm there. So this is what I know is I go in, I want big samples. I want my sample to be huge. So I'll go 50 or even 60 here. I don't need a ton of samples, you know, so I crank that row, the number of samples per row down, and then I just hit generate, you know, and you'll notice it didn't put any samples down here or up here in the corner. So if I see that, I'll go in and I'll put some. Now, some of the people that I listen to, some people that I've had teach me, you know, they'll be very methodical about going in and placing their samples, you know. I'm not quite that fussy, and maybe I should be, and, you know, maybe someday when I really tweak my process, I'll start looking at that. And the reason I make big samples is then I don't have to worry about, you know, oh, I got one placed right on this star right here. And, oh, look at that. You know, if you look at this preview of the sample, well, look at that star is taking up nearly half of that sample, you know. So if I did see that, I'd go move that off. But I wouldn't worry about getting a little star in there. I mean, I wouldn't worry about that, you know, because DBE is going to ignore, you know, the black. But what I would like is, you know, as much of that sample to be working on the noise as possible, you know, so I'm going to move it. The other thing I'm going to do is I'm going to look at where the samples are placed. I don't really like the fact that it's so close to that, because I know there's nebulosity there. Same with this one. I'm going to move it away, and, you know, I'm going to move it, you know, I'm not going to be too afraid. I also like them in the corner, so I'm going to go place one in the corner. I think I placed this one here. I'm going to go move it right into the corner, you know, because I'm not, you know, and I don't like this one here. That's a little close to the nebula, and I might put another one there.
You know, and I might put another one down here, you know, and then I saw it as soon as I placed it, this red one. Well, I know what causes that, and that's up here in the tolerance. So I'll go in here and I'll start tweaking the tolerance, you know, so I'll change that to 1. Oh, it didn't. So it didn't help it. I also like shadows relaxation. I like that at 6. So I'll just change that to 6. So then I'll keep tweaking this, and maybe I'll go 1.5 here. There. Oops. Oh, it just ran it. Sorry, folks. You know, so now it turned that sample that was red. It actually, you know, so if I click on it, it's green now, and green is good. You know, so even if you wanted to go through and look at all your samples, you know, oops. You know, you can look at each one by one and go, okay, you know, maybe that number 2, maybe that one, I'd go find it and move. What's nice about it is it lets you know, it turns green, so you know where it is and you can go move it. You know, so you can scroll through. I think that's all.
Hey, Mark.
Yes.
Sorry.
No problem.
So the way I was kind of taught is I find myself putting like 30 X's on when I try DBE. I almost never like my DBE result versus my ABE result.
Yep.
It seems like you have a lot fewer X's than I normally do. Is that better to have fewer, or is it?
Well, no, you need
depends on the image.
I guess the way I was taught and the way I have, you know, things I've read is by making bigger samples than you don't need. Because, I mean, if you add up the area of all my samples, it's probably more than the area of your 30 or 40 samples that you're doing, which are smaller.
Because you're spreading them out.
Well, no, I'm taking a bigger, my sample is bigger in one area, you know, and you know, so I'm taking a bigger sample of this image to analyze. Whereas, you know, you're taking, if your sample sizes are smaller and, you know, depending upon how your samples are placed on the image, you know, you'd have to go through and look and make sure that you move them so that, you know, like this one here probably should be moved because it's got a big star in there. So, you know, let's just move that off. And I noticed that this one over here, you know, actually I don't really like it there because I know from experience that there's nebulosity there. So maybe I'm going to push it off a little bit there. You know, to answer your question, I think that if you use less samples, a smaller number, you know, less samples per row, and then you use a bigger sample radius, it does a better job. And I'm about ready to show you that. And I'll show you my rationale as to why. So let's go down here to, so I'm going to show you what the background looks like without, you know, without applying it completely to the image. So here's the background. And what I'm looking for in the background is I want to see this thing smooth and uniform. You know, I know that there's, you know, and I've worked with this image long enough now to know that I must have been shooting with some moon that night. And I think this is some gradient or some of the moon invading in there. So if you remember the background from ABE, and actually I have it right here, you know, so here's the ABE background. You know, if you compare those two, there's quite a difference. I mean, I'm not happy with that. I mean, that is why you get that big halo around the image. That's just gross. And when you look at this, it's nice and smooth. Yeah, I would like a little more down here, but I just don't think there's much noise down there. I just don't. It must have been. You know, I'm blaming it on the moon until I know better, and until I went and looked at what night they were they were acquired and did all that work. I didn't do that. I'm sorry. I was kind of lazy for that. I was more worried about showing you, how does this tool really work? So where was I going? All right, so that's the background. I mean, it's smooth. I love it. It's uniform. It's I would like to see it a little more over there. So there are things that you can do. I mean, even though there are samples there. All right, let's get that ugly thing out of there. There are samples there. So let's just toy around with this. Let's throw a couple more in there. I don't think it makes any difference. The one thing that I do like to play with, though, is I like to use some of these symmetries up here. So you can so that one that's lit green there, you can use horizontal. So then it will look at and analyze all the way across that horizontal line of the noise, and that will include it will include that in its analysis. I don't really see a benefit there. What I really like is doing it diagonal, because then it cuts across and it will do some analysis of the noise through the nebula. And you can play with it. I mean, so all right. So we made a few changes. We added some more samples. We added symmetry to that one sample there. And let's see what we get. Let's look at our background again. And I always double stretch the background, So it looks like we picked up some noise extraction from this corner. I don't know if that's good or bad, but now I have this kind of bothers me, is I have this spot. I have a spot where, there's not. It doesn't look like it. I mean, it looks like now it's not even. It's not uniform. So that does bother me a little bit. So I don't know if I like that. So let's take that diagonal off, and then let's try it again. I really experiment. I really play around with it, and I'm still not happy with that. We went and added some samples there. I think I'm going to go delete them, actually. So let's take that one out of there, and you can just highlight it and just make it green, and then just hit the delete key. You could also highlight it and go up here and hit this red X, and then it's gone. And then, there's another one. Let's see what happens when we take and do less sampling in that corner. I don't know. I'm still not very happy with it, but I can't get it to where I had a nice one. I had a nice one yesterday or the day before or something like that when I was playing around. Let's see if I saved it. Let's see. Here's some background. That's not it. Yeah, I must not have saved it. So let's just go ahead and we'll apply it. That's not too bad. Actually, I want to put a couple samples in. And actually, I think what I did was I put some vertical right there. Let's just one more look, and then we're gonna say we're done playing around. And yeah, see, that's just ugly. That is not what I want as far as background. So let's take that vertical off of there. But I did get one that worked out really nice. I'm sorry, can't get it. I can't duplicate it now. So I say that's not too bad. Let's apply it and see what happens. So we'll do an extraction, and we'll do subtraction, and we'll do discard that background. We've looked at it enough, and I don't want to replace the target. And there we go. So my personal feeling is that I think this does a better job. And if you zoom in, and I'll show you some things in a second. I always do that, always go the wrong way. You know, sure, it looks lumpy and bumpy, but what I've learned is that this is now ready for MLT. And once you apply MLT to this, this gets just as smooth as silk, as butter, as hot melted butter. Let's see. Let's do this.
Hey, Mark,
Yes.
when you do MLT, how many layers do you typically between
I'll show you in a
luminance
second, Trash. Just give me a second. Let me. I'll include that.
Okay, thanks.
I got to do something. I forgot to do something when I started the recording. Sorry, all those that are watching the recording. All right, so I'm discarding this because I have plenty of copies of it already. So let's see. I have a DBE for RGB. Oh, that's what I did. Okay, so there's mine process. Let's close this one and open this one. Did I undo that? Is that undone? Oh yeah, that's original. So this one might be the one that I was looking at or looking for as my process that worked really well. We'll find out in a second. I know that. I guess I don't know if there's any difference or not. But I do know that if you go and you extract the luminance out of this, run Mure Denoise, I do DBE then on that extracted luminance, and then do MLT. It gets and then I reassemble everything back together again and do DBE and MLT on the RGB version. So here, let me just show you what happens. Let's see. So here is MLT. So I did some MLT. So this is MLT ABE. MLT. Those are processes. Where am I? Oh yeah, here we go. Here's Loom with ABE. So I took the luminance and extracted it like Doug showed. You still get that halo around there. So when you look at the background, that's all lumpy and bumpy and, just gross. Oops, I just closed that. I didn't really want that closed. And then this was with it, with my settings, still don't like it. And then if you go, a lot of ABEs. Where are my luminance? So here I did luminance. Here's my luminance with Mure Denoise, and you go in and always do that. It's lumpy and bumpy. So this is before Mure Denoise. So that's what it looked like before. So then here it is with Mure Denoise done. And did I apply? Yeah. So this has got dynamic background extraction in it, and it's had MLT done to it. So if you compare, oops, you got to do it the other way. To get these the same size and the exact same place, you can really see how nice and smooth that is, so that, you know, yeah, there's a few little artifacts there. I suppose if I sat and tweaked, I could get those better. But, you know, you could just see the difference between using Mure Denoise, DBE, and MLT. It really gives you a nice looking luminance. Then let's see, what else did I do here? So I also went and did, so this, what is this? So this is where I did ABE on the luminance, and then combined the luminance back into so I did DBE, or I did ABE on the luminance and then combined it back in, and it's just not, you know, ABE just does not do a very good job. So that's ready for DBE. I thought I had an image. I don't have an image that I wanted to. I don't have the image I wanted to show you. So here's, you know, so here's what it looked like. Here's the luminance before. Was DBE done on this? It says it was, but I'm not sure. Yeah, so this has had DBE and but no Mure Denoise, from what I can see. So this was just DBE and MLT, and I mean, it works, but I know it's a lot better when you do Mure Denoise on your luminance. It's really all I have. I mean, it's really going in there and playing with the settings. You know, going in and tweaking this. You know, sometimes I'll crank that up. Oh, so this is even a different. I mean, I experimented so many different times. I have all these different settings in here. Let's see, can I do that? This is still my. Yeah, so this is fine. I didn't do anything to this. You know, if we go in, oops, just click it. It's one of those things, you can play with it and play with it. You know, I mean, I don't think that's too bad. I mean, there's noise in there, but this is just so I didn't extract the luminance. I just went in and started working right on the RGB. I went, okay, well, what's this like? So there's no Mure Denoise done on this. This is just going in and just hitting it with DBE. You know, I know I can create a better image by going in and extracting the luminance, doing Mure Denoise, doing DBE and MLT, combining it back with my RGB image, and then doing DBE and MLT and get a nice looking image for further processing. Any questions from anybody? I've been kind of rambling for like a while.
My big issue with DBE the whole time has been I haven't found the benefit for what I do versus ABE. Does everybody know the difference between ABE and DBE?
Well,
does everybody not understand that?
I thought I covered it pretty well. One of them is automatic and dynamic. You know, you don't have a lot of control as to where samples are placed in ABE. In DBE, you have full control. You get to put the samples wherever you want.
Well, I guess my results aren't. I don't get the benefit. Maybe I'm just doing it wrong, Mark. It's probably what I'm doing.
Well, you know, Suresh, it's one of those things where you got to go in and experiment. I mean, go in and play with this tolerance, because that's got a lot to do with it too. Because if you're placing samples where, you know, where it's not gonna recognize it, you know, the sample when you place it is red. You know, if that sample is red, it's red because your tolerance is too low. So the stock out of the box tolerance is 0.5. Oh, sure, now it doesn't turn red.
Can you explain what the tolerance is? I guess that's one thing. As I've played with it, I don't understand what tolerance is doing.
I cannot explain what that tolerance is. It's the tolerance. So okay, so here what it is. It's the tolerance of the pixel rejection algorithm is what it says here. So it's to me it's how wide or how much tolerance it's going to give to the pixels in that sample. If you saw when I had that red sample,
Mm-hmm.
it was
Yeah,
rejected.
I think it's right. You can see it in the graphics on the side. The black images, if you have too much of that, if you lower the tolerance, it will change the behavior there. I think
Right,
just
so-
you need that number and just change the tolerance.
Right. So if you look at the sample right now, this the preview of the sample, and now if I change that to actually let's change it to 2. That's a huge change. So what it's looking at, I'm looking for a better explanation of that. So if you have, I don't know how to explain that. Yeah, okay, so it's right there. Increasing this value favors inclusion of more pixels in the background model. So if you have a red sample, it's because there are so few pixels that are going to be included that it isn't even going to be part of the process. And actually, I don't even know that the process will run.
Move the tolerance down. Let's see what happens when you move to like 0.1.
There, okay. Oops, and I hit. So it will run.
But you can see in the preview, in the dialog box itself, those are the pixels it's going to use, and there just
right.
really aren't very many pixels that
Right,
it's going to use.
Right.
You're not going to get a good estimate of the error or the noise or the gradient.
So the larger the tolerance, in a sense, the more pixels you get.
Correct.
Yes.
And you want more pixels
In your sample.
Well,
Your
you need to be careful about increasing it too much, because then it starts to use, stars and edges
Right.
of stars in the estimate of the background.
Right. So if I look at this estimate of the background, look what it's doing to that 1 star. So maybe I want to lower that. I think it worked at 1. And actually, I forgot. When you change that tolerance, you actually have to hit resize. So look at it. Actually is. It probably should go back up again because it's messing with those stars on the edges. Now, sure, that's a sample that's way off. So let's take it up here.
Put it on the nebula.
You never put a sample on the nebula. Look, it turns black.
Mm-hmm.
So it really isn't going to have any effect on the nebula at all. And actually, that it's red. So which way does it have to go? Does it have to go to 3? There, now it's green. But look how much of look how much of your sample isn't even being used.
The reason you don't want to put stuff on the nebula is that, well, the nebula can look like a gradient. And then it thinks it looks like that's background, and well, you don't want to remove the nebula. So
Right, exactly. You don't want to mess with the nebula. You want to mess with the background. So let's see. Do I have anything? So that was DBE and MLT. I have another project that I have processed farther. So let's close that. So that's before. This is my luminance untouched, and this is my luminance. This is after DBE. Yeah, so that's after DBE and only has MLT applied to it. So this is my luminance after. So this is luminance after Mure and DBE and MLT. You know, to me, I think I did some good to the luminance. You know, let's see, do I have an RGB? Let's just combine those. Don't want that one anymore. Let's hide that one. RGB, DBE, RGB, DBE, MLT. So I would take that one and I would do LRGB combination. I got to go choose that image. So that's this one. Watch it get all ugly because I've never done that before. So, yep, it got ugly, but unstretch it and then restretch it. And maybe it is uglier. But, you know, you don't want to mess with it too much because there's a lot of nebulosity out here that I know is there, you know. Always the wrong way. But this is the part I like, is that it's all nice and smooth in there now. So now, as we continue to process this using histogram transformation, and you know, maybe you go in and you put a star mask on it, and you know, you turn that background way down using the histogram transformation, you know, and just turn that background down, and then your stars are, you know, you haven't messed with the stars, or you use maybe a range mask, which I think you would do. Doug knows masks way better than I, and maybe someday I'll get good at masks. You know, if you go in and do a range mask, I guess, and then turn everything down in the background, and then you can start bringing this other stuff up. And you know, the Orion Nebula is very hard to process without using high dynamic range. You know, I've seen that. So
yeah, that was my last imaging session lesson learned. I finally got Orion peeking out between the neighbor's trees, and then what did I do? I just way overexposed the middle of it.
Yeah,
so
right. Because I mean,
next time I need to go around and try to get a shorter exposure and do the HDR on it.
So I mean,
well, the problem with the Orion Nebula is that you want to take a bright picture. Well, you want to take a picture with less exposure or less gain ISO, so that the trapezium isn't overexposed. You can see those 4 stars.
Right.
But then you want to take pictures at a bright level to be able to get the nebula that's around the edges that's very faint. And then what you do is you use in PixInsight, you use an HDR combination to then combine those, and it turns out very nice.
Because look at
that's my next, when it warms up and clears up and I clear a spot for my setup, which at this rate it's weeks yet.
May.
Yeah.
Well, the problem is that Orion is starting to disappear on us.
Right. Orion I really just have it peeking, you know, through, it'll go behind the neighbor's roof next.
Yeah, my plans are to get out maybe on Monday or Tuesday night. Looks like it might be possible, either to ELO or CGO, and take pictures. But
yeah, let me know if you're going.
If it's night, I might be
It's supposed to be 40
temp-
degrees one day.
Yeah, the problem is it's going to be cloudy.
Freezing rain.
So, I mean, I think it does a pretty good job when you use Mure Denoise and MLT and all those guys. You know, you line up those noise reduction processes early in your processing and just get that noise out of there.
The denoising and then MLT.
Yeah. So
No, you're going to do. Go ahead.
So what I do, or what I did on this, is, so if you look at this luminance picture right here. So I went in and I took my original RGB image. Let's get this out of here. Took the original RGB, extracted it using this button here, and then I did the Mure Denoise like Doug showed earlier tonight.
Mm-hmm.
Then I did DBE.
Okay.
With the settings that the settings that I had in my presentation, and then I did MLT. So Suresh, you wanted to see. Let's see, where is my MLT?
Things
Yeah, I was wondering how many layers.
Yeah.
So I usually don't go past 4 with
So-
either luminance or chrominance. It
So
seems
here's
like
my MLT for the luminance part of the RGB. You know, so if I'm doing MLT on RGB, I'm doing 6 layers. I'm hitting the small scale stuff really hard. You know, I got everything jacked up, you know, because if we go back, let's see, where is my original RGB? Let's go look at what they call the scales. And, you know,
so when you
so-
say you use
it's
6 layers, what do you set the noise reduction to for those layers?
Oh, so yeah, okay. So this is the other
Right.
thing. Hang on one second. This is
Okay.
this is the other thing that I do with. So here's
90.1.
my master light. So this is my RGB. This is after stacking. I haven't done anything to it yet. But let's just go in. We Doug did a good job on this, and we were looking at noise. So, you know, like Bala said, there's not a lot of noise in there, but we can make that better. So what I usually do is I want to go see what that is, and so I turn on the preview and I turn off the stretch because I want to look at the mask. That's the first thing I do is I set up a mask, and this is on the RGB. And I go in and I start tweaking around on it. You know, I will go, okay. You know, that's probably too much amplification, and I'm usually down here somewhere around 60. You know, this image I noticed it was less. Other images I've seen, I'd be all the way up to 200. You know, that's way too much. I want to get rid of some of that stuff. So I'll get it down here. I mean, you know, 30, 40, 50, you know, and smoothness, you know, sometimes my smoothness is way up here and sometimes my smoothness, I think on this, I had it set at 1. You got to create a mask because you want to protect all those stars and the details of the nebula. You know, you do that with the stretch off. You set your mask with the stretch off. And then you turn the preview mask off. And then you go and you stretch it again and let the preview go. And this is a recent improvement to the PI on the real-time previews, is it lets you go in and do a window. You know, so you do a window and then so this is what happens. This is how I evaluate whether or not MLT is doing what I want it to do. Is I go in and I start turning these. So let's fold that up and let's open up the noise reduction. So
I'll turn that off and I'll go, okay, is layer 1 doing any good? You know, and it's kind of hard to see what it's doing, but if you watch real close, and I don't know how well it shows up in your screen, but it shows up on mine. Oh, what's going on?
It says ready.
Yeah, again, why doesn't that do that? All right, let's totally mess with it. I don't know if you guys can see that.
Zoom in farther. Get a smaller preview.
Oh, it's going to take. There we go. Okay. Maybe you're right, Doug. Maybe I was too far out.
I mean, a layer 1 is pretty small scale.
It is. It's very small scale. You know, so if I turn it off, so it's on. Now I turn it off. You can see it. I can
see it. Yeah.
It gets coarse. You know, if you turn it on, it gets finer. So then if I go to layer 2 and I turn it off, and then I turn it back on again, you can see it really, to me, it really makes it smooth. You know, and if you're wondering if you got your mask adjusted right, you know, watch your stars. You know, because you want to protect those stars, and that's what you're doing because they're all black. You know, so anything that was light in that mask is what you're going to be making adjustments to, and that's exactly what we want to make adjustments to. Is the background.
How much nebulosity did you have in your mask?
How much?
In this?
Okay. Oh, okay. We can go back there. So
yep, I'm almost caught up.
I'll just leave it at this view and hit preview mask. The only thing is remember the stretch is on, so you got to take the stretch off. You know.
Okay, so
here I'll back out. I'll back out. You know, and so I've kind of played with that. I mean, even at this point, you could still play with it. You know.
Right.
You could put a bunch of nebulosity in there. So let's do that. Let's leave it there.
Yep. Yeah, that's kind of what I was looking at. Don't let it touch that stuff. Okay.
You know, don't touch that. You got to put the stretch back on again because it's in the preview. It's in the real-time preview. You know, I mean, that'll look half bad. You know, so let's zoom in again. And I always like to have, you know, I want a few stars in there. I want to see what's happening to those stars. You know, we have 2 iterations here. Maybe that's too much. You know, and one of my teachers has said, "Oops, I just turned the mask off." One of my teachers has said, "If you can see it, you know, if you can see it in the image, you've probably done too much." But you know, we're in a preview. We're in a zoomed up. You know, we made a window of our preview, so we're way in there. It's subtle, but I think it's great. You know, and when you go down to the 3rd layer, you know, you're going to see some things. I mean, I played with this for quite a while before I got these settings. And I think that's what you have to do is you have to be patient and find out what settings work for your camera and your set of data. You know, sure, you can use these to start, you know, but I don't know that these settings are going to work for everyone. You know, you're going to have to go in and tweak them for your data and for your imaging system. So this was this the luminance one? I can't remember which MLT I have here. Maybe I'm messing with the wrong one, but you know, so that's what I know about MLT, and that's, you know, I learned that my MLT process got better when I learned about the linear mask, you know. And I still say it's an experiment. So, you know, I guess we went in and cranked up that mask. So look what it's doing. I mean, it's having less of an effect on that background, I believe.
Hey, Mark, do you run this for RGBK components as well as luminance? And
Right.
luminance?
So I run, and I know Doug does this too, is he runs the RGBK and he also runs luminance. And I use different settings for luminance.
I run it on luminance and chrominance.
Chrominance, yeah.
chrominance.
Doug, you taught me not to do RGBK, right?
Yeah. Well,
right, so see,
I've
see what
never
happens.
experimented with RGBK, and I'd have to find out a little bit more about it before I think I would say don't do it. But
Mark,
that's
what benefits do you see in RGBK?
So, all right, so here, I just switched it. I left the mask alone. It looks bumpy on the chrominance side. So now if I go change that to RGBK, wait for the donut to stop spinning.
It takes mine a long time to stop.
Yeah, mine's done now. You know, I think that's a little smoother. I think a lot of it gets into your personal preference. So here's the luminance now. Just remember, we went and messed with the mask too. So, you know, but there's the luminance. I mean, I can make that thing smooth with the luminance. And I think I think that has something to do with the work that we've done and with Mure Denoise and the work that we did on the luminance version of this image. And by combining them back, I just think that background is more luminance now, or in the luminance realm, rather than the RGB or the chrominance version. I mean, to me, it's the luminance. You know, once you do it on the luminance, I think you have something that you can work with, something that is pretty darn good. So let's see. I think, do I have? I don't know what the heck. So this is.
we need to be tying things up here too.
Yeah. Well, that'll run for a while. I won't do that. I won't do that to you. So that's. I mean, I didn't want to get too much into MLT tonight because we were supposed to do DBE, but that's my process. And Shresh, you brought that up, and that's fine.
Yeah, thanks for doing that.
So let's see. I thought I had a final image. I have so many things open. Let's just get back. RGB, MLT. That must be this one right there. So, I mean, for me, that's not bad. I mean, all this stuff that I see out here, this is not noise. To me, that is nebulosity. That is stuff that I'm going to work on in the next phases of my process. I mean, if I would have taken that out, I'd be upset. You know, I mean, if you go back and look at this RGB, EBE, MLT, I mean, you've lost some data in here by having that halo around there. That's just me. So that, I mean, that's my process. That's how I go through it. You know, to me, I'm still learning. From here, it becomes a challenge to get the colors and everything right from here. You know, my next steps to master are masking. You know, because you can go in here and you can work on this nebulosity with masks and just totally bring this thing to life.
Blue tape works better than masking tape.
Yeah, it does. And I've learned that yellow frog tape is good for fragile surfaces still. That
okay.
works really well.
Doug, sounds like another topic for next time, masks.
Yeah, somebody's got to learn it first, though. Doug's
I
got it
know a
down
little
pretty
bit
well.
about it, but
Yeah, when I initially processed your image, I saturated and every star became the same color like the nebula.
You know, and I guess the other thing that I do is when I do LRG combine, you know, when I do this process, I actually go in and make these images non-linear before I combine them. I guess that's the part that I didn't talk about is, you know, I turn the stretch off. What is this? RGB, DBE, MLT, you know, and I turn the preview on and I go in and start tweaking. And what I don't like is I don't really have an edge here. Because if you look at this, if you look at the shadows, I don't like the fact that I am clipping 798 pixels. You know, and the other thing is this is a difference I think between Doug and I is the background is still too dim in my opinion. I'm in that realm of 10% black in the background, you know, so I'll keep cranking this up until I get that.
I don't like completely black backgrounds either. I think it just doesn't look right.
And I know, but I think, you know, you probably have a little more. This image isn't what I would say where I wanted it before I started doing this, but it gives you an idea of where I am, or how I stretch. So I don't know. Those are things that we can talk about maybe for future things. We can put those on the agenda. Maybe send us some ideas. I mean, you guys send some good ideas as some processes you want to look at. Heck, I'll go to school and figure it out and figure out a good way of presenting them to you and teaching you what I know about it. I certainly don't have a problem with that because it's going to help me. I get more out of preparing for one of these than I do if I'm just sitting toying through the books and toying through the videos that I have and things like that. You know, and I guess I'd be amiss if I didn't throw out a plug. You know, Warren Keller, you know, the guy that wrote the book, and Ron Breacher, who was his advisor and proofreader and all that for the what is that? What is the book's name? Inside PixInsight. You know, I follow those guys. I will go and watch anything that they have. You know, they have a website now called Masters of PixInsight, where, you know, they do periodic workshops, and it's a 2-hour workshop, and they'll do topics, specific topics, and you know they have one out there, Masters of PixInsight. It's Unmasking Masking, I think is the name of the video. It's 2 hours long. You know, for $35, you can learn it. Or I guess, you know, since I have it, I can go to school and learn it, and then come back and teach you guys. You know,
I was wondering if you were going to get a little extra for every one of us that bought into it.
Nope. And I wouldn't want that. I wouldn't want that from them. I would say, hey, I mean, to me, they know this stuff. I mean, Warren Keller has been doing PixInsight since PixInsight started, and you know, he and Adam Block. Adam Block is another one. I mean, Adam Block has a a ton of YouTube videos. He has a great video on WBPP that I wasn't convinced.
He's doing a presentation on it on Saturday for free.
Yeah, that's the new one. So that's the new version. And you know, if I'm not doing anything Saturday, I'm certainly going to be looking that one up because I watched. When WBPP first came out, he had a 6-part, almost 35 to 40 minute session on WBPP. I think I watched it like 3 times.
He has the same thing now also. Like he has 6 or 7 videos on the new WPP.
You know,
I've watched them. They're really good.
I know.
A lot.
And I did take few of the courses in their website. It is good.
So that's my plug, is if you guys really want to get into it. And then, you know, you can watch and read all you want. If you don't load data and process data, to me, that's where I have picked up experience and really made improvements in my processing. You could watch me or Doug or anybody else demo this night after night, and I don't think you're going to get that much improvement until you load up a set of data and you start doing it yourself. You know, the beauty of it is you can always go back. You have that master, and you can go back and do that. Yeah, Mike, I saw your comment. I also own Rahilio's book on mastering PixInsight. I have it by my placemat for lunch every day, and I read 2 or 3 processes every day at lunch.
All right, yeah, that was one that I was tempted to buy.
Without a doubt, I would totally do it. He has a little, to me, he's a little more disorganized than Warren is, but what, you know, between that and the book that he has and the reference guide, you know, sometimes it's a little difficult to put those 2 things together, but
okay,
you certainly can do it. I don't see anything wrong with it. They are, you know, Warren Keller and Ron Breacher, they both recommend him. They even talk about Adam Block too, but they're more pointed at Rahilio.
Does that one, does Rahilio's help guide you to play with them, like you're showing?
You know, it's for me, that part is hard to follow, to go, okay, these are the settings you want and this is what you do. I was more reading it for, you know, okay, I've got this ugly data set, how do I make it better, you know?
Right.
And, you know, and the moral of the story is well, don't collect bad data is really where you start with that, is go get good data, you know. But we live in Minnesota, we have subpar seeing most of the time. You know, we fight clouds all the time. We fight transparency, you know. You know, we fight our equipment because it's cold and froze up, you know. So we have all these things, and
fight mosquitoes.
Right, exactly. You know, so we have all that stuff. So you're going to get those nights where you're not going to get perfect data every night. So we wind up processing some of that stuff that's not quite so good, and you know, we stick that away in the library, and then next year or next summer we go collect that data again on that object, and then we go through and sift out the good stuff from the first stuff we took and mix it up with what we got. You know, that's the way I kind of see things, and that's why sometimes it'll take you 2 years before you get a data set that produces an image that's appealing to you.
Let me throw out one other place. If people are on Facebook, there's a PixInsight for beginners group that you guys should check out. There's a lot of.
I will say, I'll just caution you on that, is that sometimes there's some bad information there. Where
Right. Warren Keller actually called that out once.
Yep.
But I've actually picked up some things. People will ask questions, and then other people, Adam Block, for example, will jump in and answer it.
And that's the beauty, is when you see Warren Keller and Ron Breacher and Adam Block and Rahilio jump in and make a comment, that's when I sit up and I go, oh. So those are the guys that I trust. Those are the guys that I follow. You know, I'm not going to listen to somebody that I don't know or haven't don't have any experience with, because I would say, well, I got to be careful. I got to be careful of that information. So, you know, Warren's got some free stuff too. There's a easypixinsight.com or something like that. He's got data sets that you can download, and I think he gives you icon sets and all that stuff. And, you know, you can go in and process data that he has produced and try to replicate what he's done. I did that probably 2 years ago because that data has been around for a while, but it's still relevant. I mean, you could still go in there and pick something up. I'm almost 100% sure of it. And he's got it for one-shot color. I think he's got some for DSLR, and I think he's got LRGB, you know, filtered.
And that is how I used that tutorial, the free one, to first try out Doug's image M33. That was my first one.
Yeah, that's it's a great source, great resource.
Yeah.
All right, I'm done. My mouth is tired. Thank you, everyone.
Okay.
Well, thanks a lot.
Thanks, guys.
Doug, when are you having a session on picking the cameras and guide scopes and scopes?
We can work on putting something together for that. You're just looking at the equipment to buy.
Yeah, I was thinking about you know, a camera. At least I thought I'll get a one which is used for a guide camera, but I can also use for my, you know, the planets using my Nexstar. So I was wondering which one to buy. So that's how that question came up.
Okay. Why don't you send me an email on the specific topics that you kind of want or what you would like me to cover?
Yeah, we'll do that.
Suresh, I think that you were asking about a month ago for a session on LRGB, or was it? No, it was narrowband, wasn't it?
Narrowband in general, yeah.